Let's graph an ellipse from a given general form of an equation. This is now the last video for the ellipse. In the previous video, we were able to graph the ellipses for numbers 1 and 2. But since we already have separate videos for determining the details, it's easier for us to plot them. However, for number 3, this is in its general form, so we don't have the details yet. So our goal here is to come up with a general form, the standard form, to get the details for us to graph the ellipse. To do this, let us try to isolate the constant to the other side. So we have here the equation 3x squared plus 2y squared plus 6x minus 8y, and move the negative 1 to the other side. The next thing here is to pair the terms with the same variable. 3x squared plus 6x plus 2y squared minus 8y is equal to 1. And then factor out the common number. So you will have here 3x squared, and then factor out 3, you will have 2x. And the other side, factor out 2, and you will have y squared minus 4y, and then is equal to 1. That factor out the variable because our goal here is to complete this, because by completing the square, we will reach the expression h minus x over a squared probably, or a b squared, depends on which is the larger value, and for the y as well, like this. Okay, not forget that this is our goal. We will have same with the equations of the parabola and in the equations of the circle. We need to come up with a perfect square trinomial so that we could have a square of a binomial here. To do this, we do have the formula to get the value for C. We have been repeating this since the circles. This is equivalent, but not the C that we're talking about here, huh? The C that we need here to for this to be a perfect square trinomial. So let us just not label it a C for to come out to have no confusions. So we have here the value for 2 over A 2, sorry, that's b over 2 and then square root of a, which is 1, and squared. This is for the x. And for the y, you will have negative 4 over 2 square root of 1 and then square it. Okay? Here, that's 1 squared, which is 1. That is what we need to add here. And as well for the other side, negative 4 divided by 2 is negative 2. And square it, you will need 4. So you need to add these two things for these specific pairs of terms so that we can come up with a perfect square trinomial. Okay, and to do that, we will have this. We'll have this expression 3x squared, sorry, that's squared, plus 2x plus 1, and then plus, that's what we added here, 1, 2, y squared minus 4y plus 4, the 4 here, is equal to 1. But we need to make sure that we could actually, what the term is not negate. We are going to check or verify that what we have added there will also be added on this side so that we retain the original equation. Is it plus 1 and plus 4? Because these are the results. If these are your answers, then we need to understand this properly. Yes, we added here 1 and we added here 4, but for this right-hand side, it's not 1 and 4. Why? Look at these terms here. We do have these terms just outside the trinomial. Make sure, take note that these were just taken out earlier, and then they could actually be returned there, as well as these two here can be returned there. And if we do return it to the constant that we have added, what we added here is not actually 1. What we added here is actually a 3. By factoring out the 3, that's why it's just simple 1 here. So instead of adding 1 on the other side, what we will add here is 3 times 1, a value for 3. Similarly, for the value for this y group here, it's not 4 because there is a constant outside which is 2. And if we do return it, it will become 2 times 4. And it's not actually 4, but it's rather 8. Again, I repeat, it's not 1 and 4 here. Whatever you solve to this, yes, they are the one to be added for this expressions to become perfect square trinomial. But for the other side, to retain equality, it's not 1 nor 4 because it's actually 3 and 8 since there are coefficients right outside them. So just to correct that one. So here you will have 3 and then square root of the first term x, square root of the last term 1, sine of the middle term x. That's your square of a binomial now. On the other side, you will have here plus 2, and then square root the first term y, square root of the last term is 2, sine of the middle term minus, and you square it. And on the other side, you will have 12. Okay? So again, this is what happened here. To get the standard form, and why do we need the standard form? Because that is where we can get the vertex value for A, B, and soon let C. That could be help us determine the vertices, the foci, and the covertices. We need to divide here both sides by 12 because the standard form is where it is equal to 1. So if it's equal to 1, divide this by 12 as well, 12 as well here. So 3 divided by 12 is 1/4. This would mean that the result here is x plus 1 and the square of it over 4 plus, for the other side, 2 divided by 12 is 1/6. So you have here a 1 y minus 2 squared over 6 and it's equal to 1. This is the standard form of the equation. Right? From this, we can get the center. The center is given by these points here, but it should be x minus, sorry, it should be x minus h, the square of x minus h, plus the square of y minus k over, now look at the value which is bigger than the other. 6 is bigger than 4. This is where we will see our a squared, and this is where we'll see our b squared. So our our center, let's see pala. Our center is x minus h, and this is x plus 1. So this is actually written or can be written as x minus negative 1. So our center is at negative 1, and then this, no need to fix this, it's ready. Okay, negative 1 and 2. This is the center of our ellipse. As for the position, simply look at where the a squared is written. Again, a squared is still bigger than b squared. So a squared is 6 and it's written below the expression with y. So it's actually vertical. So it's vertical. So a squared is 6. So the square root of a is plus minus square root of 6, but the positive will be taken, square root of 6 only. For the b squared, it's 4. So b is positive 2. Square root of 4, positive negative 2, but then again, we only accept the positive answer. With this, we can now get the vertices. The vertices here will not use the 0 plus minus a or the plus minus a 0 formula. Why? Because our center is not anymore at the origin. That is only the formula for when the center is at the origin. You may look at your notes to get the formula for the vertices. The vertices for vertical ellipse where center is not at the origin is given at h and then k plus minus a. The covertices is given at h plus b plus minus b rather, and then k. And the foci are given with the formula h plus minus sorry h k plus minus c. Okay. Again, these are the formulas in your module. You may want to review them. No need to worry. You're still in the process on reviewing Pamampad. So here, our h is, this is our h, that's our k. So here, our vertices will use this h and k here. And h is negative 1. And then you have here k. K is 2 plus minus square root of 6. So our vertices, vertex 1 is at negative 1 and then 2 plus square root of 6. And the vertex 2 is negative 1, 2 minus square root of 6. Our covertices are located at negative 1 plus minus 2, which is your B, and then K, which is 2. So core vertices, co-vertex number 1 is at negative 2, 1 plus 2 is positive 1, 2. And then the co-vertex number 2 is negative 1 minus 2 is negative 3, and then 2. These are the points that you will be placing later. As for your foci, C, we still need to get it using the formula C squared is equal to A squared minus B squared. And your C squared, A squared is already 6 and B squared is 4. So your C squared is actually 2 and C is plus minus square root of 2 or simply just the positive square root of 2. And have it here. So your focus is at negative 1 and then K, which is 2 plus minus square root of 2. So the first focus is at negative 1, 2 plus square root of 2. And the second focus is at negative 1, 2 minus square root of 2. We have ready our foci, our covertices, our vertices, and the center. Let's plot them in this Cartesian plane. So let's look first at the value of 2 minus square root of 6. You can use calculators for this. Square root of 6 and then plus 2. Before we graph, let us try to determine first the value for this with items with irrational numbers so that we will not have any problem later. So you have 2 plus square root of 6. You may use your calculators if you want to. Okay. So you have 2 plus square root of 6 is equal to 4.45, more or less, approximately. Second is if you get the 2 minus square root of 6, you will have negative 0.45. Okay, negative 0.45. And then for the foci, which is 2 square root of 2, you could also try to use your calculators if you want to. 2 plus square root of 2 is 3.41. And for the second foci, you will have here 2 minus square root of 2. 2 minus square root of 2, which will be more or less equivalent to 0.59. 0.59. Okay, Let's plot all of them in this Cartesian plane. Center. Let's start with center, -1. Let's have it by the largest point is 4.45. So by 2 probably. 1, 2, 3, 4, 5. Okay, by 2 per 1 unit, so that we will have a better form of the graph. Okay, by 2. All right, so we have -1. This is -1 here, and then +2. Uh, -1, +2. So this is where your vertex is. Vertex, -1. Sorry, I've keep on repeating the term vertex. This is your center. -1, +2. And then for your first vertex is at -1 and 4.45. -1, 1, 2, 3, 4. So more or less 4.5 here. And for the other side is you have negative point, because that's 1 at 2.5 more or less. 1, 2, so 0 point here, almost half. Okay. Your co-vertices is at 1 and 2. Let me use the color blue. 1. This one here, and you have here 2. Okay. And on the other side, you will have 3. -3 somewhere here, and 2. Right? And your foci, colored pink, you have -1 and 3.41. So 1, 2, 3. So more or less here. And 0.59. So more or less here, 6. Okay. So these are your points. By the way, I forgot to place here the points. So we have, this is -1 and 2 plus, that's plus square root of 6. And here you have -1. This is your vertex here. Another vertex, -1 and then 2 minus square root of 6. For your covertices, this is CV. We have 1 and 2. Yeah, another CV here, -3 and then 2. And finally, for your foci is here. Foci, -1 and 2 plus square root of 2. And at the bottom, you'll have your foci here at -1 and then 2 minus square root of 2. Okay? Pardon for not so very good handwriting. But anyway, we have these points. And let's have our ellipse now. And it should pass through the vertex here and the vertex at the bottom. And this should stretch vertically. At the moment, it is stretched horizontally because we have not passed through the co-vertices. But if we do this, like that one, and the co-vertex here on the other side, you will see that the ellipse is a vertical ellipse as claimed earlier, with the equation for this in its general form. So this is the graph. So it's a little bit longer. Okay, don't need to worry. Just relax. Take one step at a time. And if it's too tiring for you, stop. Take a deep breath. Drink a lot of water, and then return. I don't need to rush things up. So this is the graph for item number 3, which is still given on the general form. The things that you did here is, to get the standard form, we have to factor out the common monomials here and then complete the square, but make sure that for the other side, we are multiplying, or rather, we are adding the product of the common monomial and the term that we have added here. And then, as soon as we are done with our standard form, decide the center position so that you could get the value for A and B and the rest. And here is your graph. Hopefully, this will entice your understanding. I know for a fact that it's not that easy, but I am hoping that this could actually give you more time for analysis. Thank you very much. See you soon. Goodbye, everyone.